Okay, now we're talking about how to find compound interest. And there's a formula we talked about, but really I don't want you to be confused. It's all just from the same generic exponential function. This first number represents your initial, this is your growth factor, and this represents kind of the time that we're waiting here. So the formula we're going to use is PERT, A equals PERT. So A is your final amount, and P is like your principal, which is your initial deposit, which matches up to A. E is not a variable. Remember, it's the number E equal to approximately 2.71. That's your growth factor. It's growing. It's greater than 1. It's 2.7. The key is when you compound continuously. So if you keep compounding not once a year, twice a year, 4 times a year, not even every day, but you do it every second, it approaches this number E. So that's a number. It's our growth factor. That corresponds to this guy right here, the B here. And this is our interest rate times the time. So that's time right there. So we use this PERT formula, but don't be confused. It still comes from the same old exponential formulas. Okay, so let's go ahead and apply this now. Number one, you invest $3,000 in an account that gets 6.5% annual interest compounded continuously. That word continuously tells you that you are using E. You're using this E as your growth factor. So how much is in the account after 5 years? So our A equals, you can put Y if you want, don't care. Our initial deposit of $3,000 times E to the R times T. Well, what is R? R is 6.5%. Remember to change it to a decimal. Move the decimal over twice, boom, boom, so 0.065. Remember, we don't add 1 to this. It's not B. We're not trying to find a B here. This is our B. This is our growth rate. It's E. So we don't need to change R at all. So 0.065 times our time, our T time, which is 5 years. Okay, sorry, let me section this off. All right, so we're going to do this. Remember, don't do the multiplication. Do this part first, then take E to that power. So 0.065 times 5, 0.065 times 5 equals that, 0.325. We're going to take E to that power, E to this power right here. So we push the second E to the X button. There we get 1.384. Then we're going to finally multiply that by 3,000. And we get approximately equals $4,152.09. Okay, let's just do the same thing, except part B. Let's wait 25 years instead. So initial deposit of $3,000 times E to the rate 0.065. And then instead of waiting 5 years, we're going to wait 25 years. Everything else is the same. These problems are pretty, just kind of plug them in. 0.065 times 25 gives us 1.625. Then we're going to take E to that power, so E to the X gives us that. We multiply by 3,000. There we go. So we're up to $15,235. $15,235.26 rounded up. All right, so those problems are pretty simple, straightforward. Number 2 is a little more interesting, though. An investor invests, she withdraws all $525 from the account that she left, untouched for 8 years. Okay, it earned 3.4% annual interest compounded continuously. Again, that word continuously tells us that we're using E, the PERT formula. How much was the initial deposit? So this time, we're not looking for A. Let's just write the formula down. This time, the question is not what's the final amount. We know the final amount. The final amount, she withdrew all $525. This is your final amount. We know the rate. The rate is, let's see, 3.4%, which means you move the decimal twice, boom, boom, 0.034. Okay, so we have E to the 0.034, and we also know the time. The time was 8 years. Didn't touch it, so we actually need to know the P here. So let's calculate this. 0.034 times 8. 0.034 times 8. 0.272. We're going to take E to that power. Take E to that power. And now actually I'm going to try and store this to be as accurate as possible. So your calculator might have this store. So I'm going to push store, and I'm going to store it in number 2. So push 2. There goes M2. Now I've got this number here. So I've got 525 equals P times approximately this 1.3125. I'm just going to write it for fun. All right, well, that we can see clearly here, then we just need to divide by that number. So we're going to take 525, and we're going to divide by this number. And I'm just going to recall it. So recall, and then I push 2. There it is. I divide. So 399.97. Because of the rounding, I'm pretty sure that P was equal to $400, but I'm just going to put it approximately. So our initial deposit was $400. And you could plug it in here and check it, and it'll give you back to pretty much 525. So there you go. There's our 2 compound interest problems.